Okay, question 16. So a particle of mass 400 grams is initially at rest at the point O. It starts to move in a straight line such that its velocity, v meters per second, at time t is given by v equals 6t squared minus 12t cubed for t greater than 0. Part A wants us to find an expression in terms of t for the force acting on the particle. So, force is mass times acceleration. Now, acceleration is the change in velocity over time, the rate of change of velocity over time. So it's dv by dt. So acceleration then is going to be, so 6t squared differentiates to 12t. 12t cubed differentiates to 36t squared. So we got minus 36t squared. Now we know the mass is 400 kilograms. So 400 grams, which is 0.4 kilograms. So the force is 0.4 times 12t minus 36t squared. 0.4 times 12 is 4.8. So we got 4.8t minus 0.4 times 36 is 14.4. So minus 14.4 t squared. Cool. Okay, then part B for 5 marks wants us to find the time when the particle next passes through O. So we need to revise a little bit here. If R is displacement, and then velocity is the difference in displacement over difference in time. So dr by dt. So we can actually work out the displacement of the particle from our expression for the velocity. What we are trying to find is t when displacement r is equal to 0. So r then is the integral of velocity with respect to t. So r is the integral of 6t squared minus 12t cubed. With respect to t. So r is 6t squared or t squared integrates to t cubed over 3. So then we got 6 over 3, which is 2 So we got 2t cubed. Now t cubed integrates to t to the power 4 over 4. 12 over 4 is 3. So we got minus 3t to the power of 4, add c. So, we need to, first of all now, find the value of c. Now remember, we were told the particle was initially at rest at O. So, when t is equal to 0, r was equal to 0. Now this tells us that c is equal to 0 because the t terms disappear when t is equal to 0 and r is equal to 0. So, we then know r is equal to 2t cubed minus 3t to the power of 4. Now, when the particle is at the origin, r is equal to 0. So, we set our expression for r equal to 0. So, 2t cubed minus 3t to the power of 4 is equal to 0. Okay, so now we want to try and start solving this. So, we have a common factor of t cubed. So if we factorize this, we get t cubed times 2 minus 3t is equal to 0. That gives us two solutions for t. Either t is equal to 0, which we already knew, or 2 minus 3t is equal to 0. So, from this, we get 2 is equal to 3t, therefore t is equal to 2/3. 2/3 of a second is the next time where the particle will pass through O.